Welcome to our lesson on dilution of solutions. In our lesson, we are going to describe the dilution of a solution and calculate the unknown concentration or volume when a solution is diluted. But first, let us know what dilution is. Dilution refers to the process of adding additional solvent to a solution to decrease its concentration. An example of dilution is making an orange juice from a concentrate. In a dilution, a solvent, usually water, is added to a solution, which increases its volume and decreases the concentration of the solution. In chemistry, in preparing for a solution, a chemist usually add water to a stock of solution in order to decrease its concentration. Let us compare dilute versus concentrated solutions. A dilute solution has small amount of solute in a large amount of solvent, while a concentrated solution has a large amount of solute in a small amount of solvent. Usually in a concentrated solution, the particles are greater in amount than the particles of solute in a dilute solution. So usually the concentration of the solution before is concentrated. So this is more concentrated before, and after adding the solvent, it becomes diluted. So when adding solvent to a concentrated solution, the volume increases, but the number of moles stay the same. This means that the amount of solute in a given solution is the same. It doesn't change, only the volume, because you added the amount of solvent or water in the solution. But before we're going to proceed with our calculations, let us know more about dilutions by watching this video.
In this video, we are going to look at what dilutions are in chemistry, how to calculate them using a very easy equation, and even extending to multiple dilutions, which are called serial dilutions. I am sure you all already know that when you have orange squash and you dilute it, that just means you add water. It is the same in chemistry. Dilution is the process of adding water or another solvent to a solution to decrease the concentration. Exactly the same as your orange squash. You have it strong, or you can add more water and make it weaker. So you just need to remember that to dilute a solution means to add more solvent to a set amount of solute, therefore increasing the total amount of solution and decreasing the concentration. So, why do we dilute things in chemistry? In laboratories, solutions usually come in small concentrated volumes so that they are easy to store. You then need to dilute them to a known lesser concentration to use them, such as for titrations. But dilutions are really important for many other things too, such as for doctors and in microbiology. The good news is that there is a very easy equation to help us calculate dilutions. M1 V1 equals M2 V2. Let's have a look at where it comes from, and then we'll see what it means.
Okay, so in calculating for the concentration of a solution or the volume of a solution when doing dilution, you're going to use this equation, which is M1 V1 equals M2 V2. What does M stands for? Remember when we discussed the concentration of solutions using molarity. So this is molarity, concentration in molarity. Okay, and then this is the initial concentration. This is the initial volume, and when we have the final concentration in molarity, and we have the final volume. The initial and final concentrations must have the same units. For example, if your molarity is mole per liter, so mole of solute per liter of solution. And of course, your volume should be consistent also. So your volume can be in liter or milliliter. So they should be consistent. V1 should be and V2 should be in the same units. Okay, they must have the same units. So if not, for example, V1 is in ml and V2 is in liter or L, then you need to convert ml to liter or liter to ml. So they must be of the same units. So let's say, for example, you're looking for the initial concentration, which is M1. Okay. M1 is equal to M2 V2 over V1. And then initial volume, that is M2 V2 divided by M1. And then if you're looking for the concentration, the final concentration, you have M1 V1 over V2. And the final volume, you have M1 V1 equals M2. Okay. So these are the formulas that you're gonna be needing in calculating for the concentration or the volume of the solution using dilution. Okay, let us go ahead and put this in calculations or problems. Okay, we have here problem number 1. If 45 ml of water are added to 250 ml of 0.75 molarity of potassium sulfate solution, what is the molarity of diluted solution B? So our formula M1V1 equals M2V2. So M1V1 equals M2V2. So we're going to plug in the given amount of solution and the concentration and the volume. Okay, so our M1 is 0.75. That is molarity times V1, which is 250 ml, equals, we're looking for molarity, which we call it, M2. Let's indicate that as our M2, times the V2, which is 45 ml. Okay, 45 ml. Okay, so looking for M2, we have 0.75 molarity times 250 ml divided by 45 ml. So you remember your unit for volume should be consistent, so you can cancel that out. Okay, so we have 0.75 times 250 divided by 45, and you'll get 4.16 or 4.17. So your M2 is 4.17 molarity. So that's gonna be the molarity of the final concentration of your solution. Okay. Let's have another problem. If water is added to 175 ml of 0.45 molarity KOH solution until the volume is 250 ml, what will the molarity of the diluted solution be? So always make sure you know the formula. M1V1 equals M2V2. So what is our initial concentration in molarity? We have 0.45 molarity. So 0.45 molarity times your V1, which is 175. Because this is the initial concentration and volume. And then the volume increases to 250 ml. And then what will be the molarity? So we're looking for the final molarity. And then we have 250 ml of final volume. So the same thing, if we're looking for M2, it's going to be 0.45 molarity times 175 ml divided by 250 ml. So since your unit in volume are consistent or the same, you need to cancel that out. Okay. And then we have 0.45 times 175 equals, and then divided by 250. So that gives you 0.32 molarity. Okay, so that's your final concentration in molarity. Okay, let's have another example here. How much 0.075 molarity NaCl solution can be made by diluting 450 ml of 9.0 molarity NaCl? When the question is how much, that means you're looking for a volume. Okay, so M1 V1 equals M2 V2. So our initial molarity is 9.0 molarity, and then times V1, which is 450 ml, equals our final molarity is 0.075. Multiply that to the unknown, which is our V2. Okay. So if we're looking for final volume, you have M1 times V1, so that's 9.0 molarity times 450 ml, and then divide that to your final molarity, which is 0.075 molarity. So you cancel molarity and you get the volume in ml. So that's 9.0 times 450 equals divided by 0. Okay, let's do it again. 9.0 times 450 equals divided by 0.075, and that gives you 54,000 ml. So that's 54,000 milliliter. Okay. All right, let's proceed to another example. If 550 ml of a 3.50 molarity KCl solution are set aside and allowed to evaporate until the volume of the solution is 275 ml, what will the molarity of the solution be? Okay, so M1 V1 equals M2 and V2. So our initial molarity is 3.50. So we have 3.50 molarity times V1, which is 550 ml, equals, we're looking for the concentration. It says here, what will the molarity be? So we're looking for M2 if the volume of the solution reaches 275 ml. Okay, so 275 ml. So if we look for final molarity, that would be 3.50 molarity times 550 ml divided by 275 ml. And now you're ready to cancel that unit. So you get the molarity. Okay. So 3.5 times 550 ml equals, and divided by 275. That would give you 7 molarity. Did I get it right? Okay. So 3.5 times 550 equals, divided by 275. Okay, that's correct. Okay, let us look at the final problem. How much water would I need to add 500 ml of a 2.4 molarity KCl solution to make a 1.0 molarity solution? Okay, so we have M1V1 equals M2V2. Our initial concentration is 2.4, so we have 2.4 molarity times our initial volume, which is 500 ml, equals, of course, we have the final molarity here, or concentration, 1.0 molarity, and we're looking for V2, which is the volume. If the question says how much water, then you're looking for the amount of water that needs to be added. Okay, so remember, this is how much water, it's not how much volume of the solution. So first, before we determine the amount of water, we need to make sure we know the volume of the solution, the final volume of the solution. So we have V2 equals 2.4 molarity times 500 ml, then divided by 1.0 molarity. So that's 2.4 times 500 equals, then divided by 1, so that gives you 1200. So your volume 2 is 1200 ml. So that's only the volume of the solution. So how much water would you need to add to 500 ml? So since our initial is 500 ml and our final is 1200, how do you know the amount of water that you need to add? Okay, so what you need to do is you subtract the final volume. So it should be volume of added water. Okay, volume of added water equals 1200 ml minus the initial, which is 500 ml, and then that would give you 700 ml of water. So this is the amount of water that you need to add to 500 ml of 2.4 molarity KCl to make a solution of 1.0 molarity solution. Okay. Okay, so this is dilution all about. Why is dilution important, especially in chemistry? In chemistry, we have what we call as a stock solution, and they are usually concentrated solution that will be diluted to some lower concentration for actual use. Stock solutions are usually to save preparation time, conserve materials, reduce the storage space, and improve the accuracy with which working lower concentration solutions are prepared. And I have here an application of what we just did, diluting an acid with water. What would happen? As you can see here, the concentration of HCl as it lowers down, what do you think happened to the pH? The pH usually reaches or becoming more basic or alkaline. Okay, so it diluting an acid decreases the acidity and raises the pH towards 7. So as you can see here, as we add more water to the HCl solution, the pH raises, meaning to say the acidity decreases and it reaches towards 7 right here. It's becoming more neutral. Okay, we call it neutral. If the pH is 7, neutral. Okay, and do you know what type of substance has this neutral pH? It's usually the water. Okay, water has 7 pH. Okay, that is why water is safe to drink because the pH is 7. Okay, it's neither acidic or basic. This ends our lesson, and thank you for joining me again in this lesson on dilution of solutions. And I would like to thank everyone. As I have said, never stop learning because life never stops teaching.